We'll muddle through. So thank you very much for the introduction and the kind words. I'm happy to be here tonight. I don't know where to talk. I guess I'll just talk this way.
It's the microphone here, but
yeah, and that's okay. So
it's quite
yeah, it's an obvious. Those are really nice microphones. Yeah, perfect. All right. If there's anything I can do, I'll look for any messages if there's anything I need to talk louder, talk quieter, or whatever. So I think we all look good here, and we can get going. So yes, this is a presentation I gave last August to the circuit group. I'm actually doing some bats studies in my backyard, volunteering to do some bat work. My wife signed us up for that, and so I've realized we've got 16 different species of bats in our backyard, and I have yet to see one.
If you're depending on the echo meter,
yes,
ID,
yep,
be a little cautious.
Well, it's funny you would mention that because we are the control group. So we are, they're actually have got people with the proper meters, and then there's us. We're just the volunteers doing the echo meters to verify what they find. So
we are getting Sonovac software.
Yep.
Which is far more accurate than kaleidoscope echo meter.
Ah, okay. Okay, good to know. Good to know. I'm not a wildlife biologist at all. I'm a limnologist by trade. I'm a phosphorus expert. I study wetlands, so I kind of come at all the lake management work from the nutrient perspective. So that's why my interest in the algae. So with that, all of that, how do I need the clicker? Maybe I do. I think I do need the clicker.
Yeah, I do. I wonder how we do that. How do we advance it? The arrow should do it.
The arrow, where's that
on
one?
the keyboard.
Should.
Doesn't?
No.
Oh, you're kidding.
Oh, here we go. The wheel on the mouse does.
Ah, okay.
Yeah, the wheel on the mouse does. Okay, we got this, everybody. We got this. All right, we're ready to roll now. So yes, I did start a quality environmental consulting 4 years ago now. I worked at the university. I worked with Ducks Limited. I worked at the university for a bit. I started my own company in 2000. And I've been involved with the Alberta Water Council for many, many years doing policy work for the province. So lake environment policy, obviously, but all water policy for the province. So that was, I'm still on the board of the Water Council. I really enjoy that work, and you have to get me off that board kicking and screaming because I just love sitting around the room talking about water with, all the best and the brightest in the province. Every sector, oil and gas, you've got municipal sectors, First Nations, you've got all the government sectors, the feds are around the table with us. So it's really exciting work. And I get to learn about everything that's going on in the province when it comes to water. So invasive species, water management, water quality, water quantity, groundwater. I've sat through some amazing studies even today with Alberta Innovates and groundwater and some isotope work that's being done. Absolutely fascinating work there. They're trying to find out the water balance of some of the peatlands in the northern part of the province, and they can't figure out the water balance. There's twice as much water there as should be expected from precipitation, and it's from permafrost melting. Oh, wow. Shocking. It's absolutely shocking. And in the peatlands, most of the permafrost has now melted, and it's the bogs that are now melting the most, and they're trying to figure out what sort of trajectory. And not only is it affecting the water balance, but also there's acids that are being, there's carbonates that are being released, and it's driving the pHs up. So in the last 20 years, there's been a giant shift in pH trajectories from sort of, 6s to 8s in the last 20 years.
Is anyone measuring methane release?
Oh yeah, that's all part of this huge equation that John Gibson gave this afternoon. Phenomenal stuff. So really exciting, and something. So that was today. Yesterday, the EPA gave a presentation on cyanobacteria, and I was eating that up. So I actually have put a few of those pieces into your talk tonight. So there's some new bits from the circuit talk. So hopefully you'll get a kick out of it. So I'm going to dive right into it. We hear about cyanobacteria. We hear about harmful algal blooms, and they're different from regular algal blooms. Yes, algae are a beneficial part of natural environments, and only a few are harmful. So you've got your regular green algae. Okay, those are good. Harmful algal blooms can occur in fresh, marine, and brackish waters. and they can be caused by an amount of different diverse organisms, including toxic and noxious phytoplankton, cyanobacteria, benthic algae, and macroalgae. Tonight, I'm going to focus on the cyanobacteria. Those are the ones that we usually find in our freshwater systems. And that's pretty typical. Some have, so I'm going to start calling them HABs, so stick with me, harmful algal bloom, HAB. Some HABs produce toxins that have harmful effect on people, fish, marine animals, and birds. And of course, the species vary from region to region, but there are liver and nerve toxins that these produce. And I'll talk to you about some of those effects shortly. And of course, in marine systems, obviously we talk about, paralytic shellfish or red tide. Those, of course, are also harmful algal blooms in your marine systems. So yes, they do occur in salt waters as well. So cyanobacteria are not real bacteria, or they're not real, or blue-green algae are not real algae. They're a cyanobacteria. They're basically bacteria that can photosynthesize. So that's why they get the name algae, but they're not a true algae. They're a bacteria that can photosynthesize. That's their superpower, is their ability to photosynthesize. And I'll tell you why it's their superpower. And of course, this is bacteria that's found everywhere. It's ubiquitous. It's in the air. If we left a water sample out sitting on the table outside, eventually some would blow in and it would start to grow. Like you leave a kid's pond out for the summer, you're going to get cyanobacteria and all sorts of other stuff growing in it. I'm sure everybody's had a pool and tried to keep the water clean. Well, it's in the air and it'll grow. These are naturally occurring. These are prevalent, especially in calm water. They are blue-green or sort of a greenish-brown, like in the slide in front of us here. And you'll get that musty, grassy, fishy, rotten kind of smell with it as well. So when you're dealing with it. Now, here's the fun things that I learned just this week. And this is what makes cyanobacteria, it gives it its superpower. It has got this thick lipid membrane around its cell wall, this mucilage. Okay, I'm not going to get into all the science and tell you about scanning electron microscopes and all that fun cellular biology stuff, but you need to know that it's a harmful algal bloom, that this is a gram-negative bacteria, and that lipid wall is what protects it from rotifers and all the other bugs eating it. They don't want to eat all that oil first, right? So that's why there's really no natural predators of this when they start to bloom in a lake. Nobody eats it, so it starts to bloom and it's not predated on. So that's part one. This is Somenos Lake last week.
Wow.
Yeah, pretty cool, huh? That just bloomed up one morning. And I'm getting this identified, but I think that's a nostoc algae. And it just looks like something from outer space.
Yeah.
Yeah, it's got zits. We gotta squeeze some pimples. So that's a real interesting. That's just from last week. So I got that this morning. I had a coffee with the Somenos Marsh folks.
Yeah.
So certain types of bloom forming blue-green algae produce toxins, and of course those chemicals that they produce, when those cells eventually die and break open, all that toxic material gets released into the water column. Most of those toxins will degrade within 2 weeks. And the toxins can remain at low levels in the water for many months after the bloom forms. So obviously we get most of these blooms in July and August. So the toxins can persist, into August and September, right?
Okay.
So long after the bloom's been there, the dog can jump in the water, get out, lick its fur, drop dead. And this happens all the time. Vets see this all the time. Most of her blooms are toxin-free. So probably only half or less of the ones that I've ran into actually are producing toxins. And even known cyanobacteria like microcystin, about half the time it produces toxin. So I can't look at a bloom and say, ha, that's microcystin, it's toxin producing. We have to test it. So that's why we put up warnings. We don't close beaches, we put up a warning. Hey, there might be toxic products here, right? Because we've seen this kind of algae. So we're kind of risk averse that way. Some places do close beaches because of the toxins, but for the most part, we just see a bloom and we post it as with a warning, right?
Are there fast ways of detecting those toxins?
Yes, great question. there are researchers at U of A doing eDNA work, and there are field kits, and we can, if you know the genetic sequence of whatever it is you're looking after, we can do a test in a field kit at the side of the lake, and in 45 minutes have results.
Nice.
With a PCR, a quick PCR kit. So Alberta Health is now moving away from doing traditional bacterial testing and moving to qPCR techniques, because we used to, look for fecal coliforms and tocal coliforms and this kind of coliform and that kind of coliform. And those are a broad category of things that can make you sick. I just want to know about the one that can kill me. I don't care about all the other ones. So that's what Alberta Health has been focusing on lately, are the ones that can kill.
Okay.
So here's another good example of, you got some macrophytes here on the right, but you've got all that material that has blown into shore, into the shallow water by this dock, has been trapped by the dock. And so all that material is probably dying. It's all floated to the surface, and it's all blown into this one area, and it's now starting to decay. And it's, turning the blue colors as the pigments start to die off. And they could be purple, orange, they could be a whole crazy bunch of colors. But mostly they look like grass clippings or something like this. And I've got a few examples here I can zip through. But what's fascinating, what's another fascinating thing about cyanobacteria and what gives it its superpower is that they have these gas vesicles inside their cells, so that they can take on air and float up to the top, and then they can release all that air and sink back down to the bottom.
This is like ballast.
So yeah, it's exactly called a ballast. They actually call it a ballast. So they will ballast up, and there's another trick coming, so keep that one in mind. So they can come up in the daytime when the sun's shining and collect all that sun energy, and then as soon as the sun goes away, well, I'm going to head down to the bottom and get all the nutrients. So they're really tricked. So they're really good at scavenging while they're down at the bottom, or they might just come down to the thermocline and hang out there. So that's trick number one. Well, it's trick number two, right? They got a fatty wall around the outside. They got this really cool ballast. Now, pardon the science, but some of you might really enjoy this. You'll all remember from grade 11 biology that plants produce chlorophyll A, right? Most of our plants produce chlorophyll A. That's why they're green. And that is in sort of that 660, 670 nanometer range. Then there's other pigments, phycoerythrin, phycocyanin, carotenoids, chlorophyll B, chlorophyll C, and then of course chlorophyll A down in the blue spectrum. I'm sorry folks on the call can't see where I'm pointing or know what I'm doing, but you can follow along. Basically wavelengths of light going from 400 up to 700, that's our human beings' visual spectrum. You've also got the infrared way here on the right, and you've got the ultraviolet down here on the left. Guess what blue-green algae have? Pigments that can pick up all of these frequencies of light.
Cool.
Right? They can pick up chlorophyll A and D and go into the infrared and into the UV range. So then what's our first trick or second trick? They use the buoyancy. So you know how light attenuates in water, right? Red extincts pretty close to the surface, then yellow, or then orange, then yellow, then green, and then of course blue goes the deepest into the water column. Well, depending on what kind of pigments they have, they'll use their ballast to get into the right frequency of where they want to be in the water column.
Cool.
Tricky. So that's their superpower. They can penetrate various, they know that the penetration of light going through water, they will pick, they could pick the blue light as the strongest, red light is the weakest, right? The wider your, the more intensity your frequency is, the deeper you can go. So there's all the different pigments just from one cyanobacterial right there. All the different colors, right? That all the jars there. Yeah, it's really cool. This I was like, oh man, this explains so much when I learned all this. So this was just what I learned yesterday from the EPA speakers. So I stole their slides. I'm a pirate. I'll tell you right now, I stole their slides. The references are at the bottom on my presentation. You'll be able to look up these papers, but this blew my mind. I was so excited. So, Of course, they say, don't go in a bloom, don't use water from the bloom, don't have any contact recreation. It can cause skin irritation and rashes, sore throat, sore red eyes, swollen lips, fever-like symptoms. If you ingest it, obviously you're going to get sick, but you're not going to. It is disgusting. It stinks. No one in the right mind is going to drink this water. And of course, it can look like this when you stick your hand in it, which I don't recommend that we do. Of course, consumption of water that has had blue-green algae in it can cause all sorts of problems. You can read the grocery list here. Lots of pets die every year from this. And there's been the odd human death as well. And of course, in the States, there's lots of reservoirs that get blue-green algal blooms. So it's really, 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 really important to take the engineers, lock them all in a room and say, don't treat that water, because the worst thing that you can do is hammer those cells with chlorine so that they all lyse open at once and release all that toxin in a big pulse. That's the worst thing you can do. So we need to filter those algae out. We need to use some other treatment technique so that you're not releasing all that toxic material all at once into your drinking water. And of course, animal consumption, or just licking their fur, right? They get out, they get all that schmutz, the grass clippings looking stuff on their fur, and they'll lick their fur and drop dead. And of course, one of the guys that I got to know really well in one of my lake associations at Lac St. Anne in Alberta is president of the association because his dog died. And he said, that was it, that day, I'm going to do something about this. So, and just even in 2016, 4 dogs died in Quamachem and Somenos Lake. And of course, that was big news because I believe the lady that happened to was a vet in town. So that's the CBC article there. And you can click on that and check that out. Yeah, this is it here. It's a toxic algae suspected in couch and area dog deaths. So yeah, so it happens all the time. Vets see it all the time. So it's and often if you got a new vet, they might not know what they're seeing, right? Suddenly their liver shuts down or their kidney shut down. What caused this, right? What are some other health risks? Obviously, watering fruits and vegetables, not a good idea. Fruits and vegetables can absorb some of the toxins that are in the water. Cooking with the contaminated water, boiling water does not release blue-green algae toxins. You're not harming the toxins, they're stable. So it's not like the bacteria, if you boil it, it kills it, then you can drink it, the bacteria can't harm you. This is not the same thing with these kind of toxins. And then of course, consuming fish, contaminated water. Now, I haven't heard of any people getting sick from eating fish that have contaminated enough material in their livers, but apparently it can be an issue. It's funny, when I gave this talk, there was 40 health advisories for cyanobacteria. At the end of the summer, there were 44 advisories, but they only monitored 39 lakes. So we don't monitor that many lakes, but every single lake that we monitored, there was at some point in the season, there was an advisory put on it. Those advisories stay in place until the end of October, and then they all automatically come off because it's the end of the swimming season. The government of BC has an algae watch observation map, and it's all GIS driven. So you can click on some of these. And when I had done this slide work at the time, these were some of the lakes that were showing as temporarily closed. And again, there's that ArcGIS link, and you can click that in my presentation when you're reviewing it in the future here and check that out. So when Alberta in particular has a health advisory, they don't post the lake as closed. It's just a warning that's given. So they just recommend that you avoid all contact with the algae, don't swim or wade in it, don't allow pets to go in there, limit the consumption of fish and fish trimmings, all those sort of things. But beach closures actually do occur. So there's been lots of notable examples, and you'll find these in the literature and just in the news. They actually are closing the lake so that people can't use it. So there is more than just recommended not use, it's actually closed. We've got dead catfish. Of course, there's other sort of downstream effects from these algae as well. You can imagine that much carbon dying at once in your water column and sinking to the bottom. The bacteria are going to go wild eating that. They're going to consume all the oxygen, and then you're going to get dissolved oxygen sags. as well as toxins, right, in the water for fish. So there's a sort of a double whammy for fish there and fish kills. What's the main culprit here? Phosphorus, 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 phosphorus. You could argue with me that nitrogen sometimes is the accelerant in this, but it's 99% of the time it's been phosphorus. It's been a soluble reactive phosphorus that is like fertilizing your lawn. It's just like fertilizing your lake. And once you get too much phosphorus, cyanobacteria, which can fix nitrogen from the atmosphere, get a competitive advantage over the algae that can't fix nitrogen from the atmosphere. And they run rampant and they grow rampantly. And then you get that multiplicative type growth. So it's the phosphorus balance that you got to keep in check. And when your levels become too high, you are flirting with disaster. You will get these excess blue-green algae growths occurring. Where does phosphorus come from? We all know. It's from your cleaning products, detergents, fertilizers, pet waste. You'll get internal loading from your sediments, from your historical loadings of phosphorus. Every particle of sediment that goes into your lake has got phosphorus attached to it, I guarantee it. So bad or poor road construction projects, just poor earth management, construction management. We call it construction housekeeping. If you're not having good sediment and erosion control, when it rains, that stuff's going to pulse into your lake. So you'll see that brown bloom going into the lake of where you've got that fine particles that sometimes they never settle. Some of those fine particles can't settle. And so you'll see that sort of making its way into the lake and making the lake cloudy. And that's sediment. And I guarantee it's got phosphorus piggybacked on it. So
one of the things in our watershed, they have, well, from the construction in Victoria, they're disposing of the soil.
Yep.
I think we were measuring like one dump truck load every 3 minutes is coming into the watershed.
Oh.
We are the dump site for Victoria and Nanaimo. And we have a toxic soil dump sitting above us that's leaking too.
oh, fantastic.
Oh, yeah,
Oh,
awesome.
awesome.
I
Yeah,
think we have our fair share of phosphorus coming into the system.
Good Lord.
and we had a big sediment coming in when it breached
Oh,
on Friday the 13th.
Mount Poly Mine.
Yeah,
Yeah.
yeah, literally.
literally.
Same guy that approved about Holy Mine, reopening with no sediment control at all. It's the same guy that approved our toxic soil bed. Herbert Hubert funds.
Oh,
Yeah,
we got to talk.
we got the talk.
Any nuclear power rods or anything? Waste nuclear stuff?
Well, we
No?
do have full of chromium and a bunch of other stuff in there.
Oh,
We have a couple of dry cleaners.
Oh, that's good times too. All right, we'll focus on sediment and phosphorus for today. We'll get into those other ones another day. So that nutrient-rich sediment in the water increases your growths of blue-green algal blooms. And of course, you got lots of ways that nutrient-rich algae can get into the lake. How do I make this little bar down here go away?
Yeah, that'd be a good.
Can I make it go away?
I don't know how
Oops.
can you grab it and drag it?
I'm wondering if I can just go full screen. Bum, bum, bum. Bum, bum, bum. Usually there's like a full screen.
It's a hide panel.
Where'd you see that?
The sixth one down, hit more again. And then there's hide video,
Names? Hide.
That's not gonna do anything.
That helped, but there's also
Oh, that's.
hide floating meeting controls.
Yeah.
Hot dog, we have a wiener. All right, so nutrient-rich sediment can enter the water, wastewater, agricultural runoff, fertilizers, and my personal favorite, aeolian deposition, wind. And some of the lakes I've studied over the years have just wind. 50% of the phosphorus coming into the watershed is just blowing in from wind.
Yeah.
So hard to manage. It's all these non-point sources, which are very, very difficult to manage.
So we said the agricultural component of Algae.
Yep, that's ag, that's bad construction. It's big development where you've got a big open area. Like I just hate it when developers go in and they open up 3 phases of a project. They strip everything because it's cheapest,
Yeah.
right? It's cheapest to get all that equipment in at once and then off. And then the ground sits there bare for 3 years before anything starts to happen with that site. And I want to see things phased. I want to see this stripped, develop, then strip, develop, strip, and not strip the entire piece at once. And if you are going to strip it all at once, great, sediment erosion control. Every pile had better have a fence around it. Every area that you've nuked all the vegetation, you better have coconut matting or jute matting or some sort of sediment erosion control products to grab that stuff when the rain comes across, because you're just taking away all the protections out of your watershed. It's the whole reason why we want to have healthy riparian areas, is because they slow that water down and they make the particles all settle. So it's a natural filter, it's a natural barrier, and you're ripping all that out. And as soon as it rains, it just runs right into a system. The city of Calgary, a guy showed me an accelerated video in a big storm, and this gentleman had just dug out a basement. And in one storm at the city of Calgary, the entire basement filled with sediment. In one storm, in like an afternoon, just whoosh. And it was, if I hadn't have seen that, I wouldn't have believed it. And it's like, no, here, I'll show you. Here's what it looked like at 1 o'clock. Here's what it looked like at 6 o'clock at night. And it was full of sediment. And that's why the city of Calgary takes erosion and sediment control very, very seriously. And that's where the whole Alberta Low Impact Development Partnership was born from. The engineers and the folks that were really in tune with this. Proper watershed management is your best way to prevent algae growth. Effective ways to control your algae growth in natural waters include minimizing nutrient-rich sediments, lots of ways of doing that. Minimizing phosphorus, lots of ways of doing that. Limiting fertilizer use, so bylaws, banning the sale of certain, phosphoruses at Home Depots and companies like that. And lots of municipalities have banned these certain kinds of products like weed and feed from even being sold locally. Doesn't mean no one's ever going to use anything else, but it's a start. Using low phosphorus detergents and cleaning products, limiting agricultural runoff, obviously having healthy, functional, intact riparian areas, healthy, functional, intact wetlands in your watershed, nature's kidneys, everything in a good, positive state and able to do its job. So the federal government implemented regulations to effectively ban phosphorus for most household cleaning products in 2010. That regulation limits the amount of phosphorus allowed in a range of cleaning products. So it used to be like 70% phosphorus. When Dave Schindler was doing his work at ELA in the 60s, phosphorus in detergents was ridiculously high. And now it's all the way down to 0.05% by weight. But of course, you've got agricultural runoff, that non-point source pollution. It is the most difficult stuff to manage because it's coming in all over the place. And every farmer will tell you they're doing a great job. Okay. And I'm not here to point fingers at farmers, but every single farmer will tell you they're doing a great job. And why would anyone in their right mind put on something onto their land that's just going to run on? That's an input cost. Why would I put a penny worth of something on my land that's just going to disappear? But unfortunately, that's not the reality. That's not the practice. Someone else recently explained it to me as, the big operations, they have this all figured out and they know exactly how much they should be applying. But the smaller farmers have if I put 70 pounds on, I'll get this much yield. Well, I'll put 140 on and I'll get twice that yield. So there's still that kind of thinking out there. So what have I started to use for treating blue-green algae? Now, remember, I'm treating the symptom and not the problem. So the symptom is blue-green algae. How do we treat that? Remember I told you at the beginning that one of the superpowers of this bacteria is that lipid membrane? That's also his Achilles heel. What's real good at breaking down lipid membranes? Peroxide. So I can effectively nuke that lipid membrane on these bacteria with a gentle dose of peroxide. And so I put it in as the form of sodium percarbonate. And I can put in my sodium percarbonate in a balloon and it will break up the balloon. It'll look like this. And these chunks all come rushing up to the surface. And within an hour, they will all sink and they will start to get eaten by the bugs. The peroxide itself, H2O2, rapidly degrades into water and oxygen. Beautiful. So that the stuff that isn't grabbing carbonaceous material on the way down through the water column and killing is getting down into the sediments and just breaking down into oxygen. That's awesome. That's awesome. So that's a double hit. Oh, a little extra oxygen down there. And then a triple good thing, when it breaks open these cells, it also attacks the toxins,
Nice.
which is a triple bonus. The fourth thing that's really good, and I just got this result this summer, and I haven't been looking for it, but they told me, is we had just done our peroxide treatment for an algal bloom, and the province was coming by to do their fecal coliform testing. They said it was the very first time their fecal coliform numbers were 0.
Wow. That's awesome.
So I'm so bullish on this product, A, because it's cheap, B, it's incredibly effective, it works really fast, there's no residual, there's no copper sulfate, there's no copper that's left behind 5 years later. If an hour after I've been there, you'll never know I've been there, other than your lake's clean. And so this stuff is ridiculously solid. And I just read a paper today that the Americans are starting to do this as well. I've got this idea from the Dutch.
Is it safe for fish?
Yep, at low dose. The most sensitive thing in the water column is, great question. The most sensitive thing in the water column is your water fleas, your Daphnia.
Yeah.
And as long as you keep it below 35 milligrams per liter, they'll be safe too.
Perfect.
So it has no other, yet that I've discovered, no other impacts throughout the water column. And so I have been applying this in a lake that spends 40,000 a year on tiger trout and rainbow trout on their fish. And we've had zero negative impacts.
So what size of lake?
40 hectares,
And
9 meters. And then another trick is I only treat the shallows. I only go around to where the cottages are, because
That's where the nutrients are.
that's where the stuff's all happening. The light is not penetrating in the deep parts. I don't need to treat that.
Yeah.
I only need to treat the shallows. So I literally only focus on maybe 20 to 30 meters offshore. And so I do 4 or 5 laps around the lake, I'm done. So my treatments are done in a morning. And the other sweet thing to know is that you need to apply it on a nice, bright, hot, sunny day, because sun fires up the peroxide, and it has an additive effect. It attenuates the power, or not attenuates, but it makes it stronger. I forget.
And your algae will be at the top of the.
And the algae is always at the top, so I'm getting it's everything is perfect, right?
Nice.
And yeah, so this has been a real savior. The province is still kind of hung up on doing this on any public systems, so I'm only able to do this on the lakes that I manage privately, but it's been dynamite, absolutely dynamite. Another product that we use, so that's if you just want to deal with the symptoms. You actually want to deal with a problem itself, and that is the phosphorus. I really wanted to use a product called Phoslock. Long story short, Phoslock is not available for sale in Canada. It probably never will be, because the company went broke last July. But I started looking into doing some other products. This one is a micro dose of aluminum sulfate, so it's an alum, and it's a very, very low amount, but it is incredibly effective at grabbing phosphorus and dropping it down through the water column. It also has no other, as long as you apply it at the appropriate dose, has no other water column issues, and it just scrubs phosphorus out of the water column. And I've used it twice.
so.
Yep.
The aluminum chloride or
Yep.
sulfate?
It's aluminum sulfate.
Sulfate.
Aluminum. It's right on there. Yeah, aluminum sulfate. Yeah. And this stuff's been very effective for us as well. What else do I want to say about this slide? It's a little bit more expensive than the peroxide. It's also in liquid form. I've got a video of us applying it. We created a little water harrow that goes on the boat. And again, I focused on the shallows, along people's docks. And there was, and I don't have any scientific data about how the plant communities were decreased, but they said that their macrophyte growth was knocked down about 80%. Just anecdotally. And they were super happy with that. Because they have divers that actually go in and cut macrophytes by hand every summer. That's how they were removing all their
So
plants.
that might be an option for your milfoil.
I got a product for your milfoil, as long as we can get approval to use it. That's the CPRO chemical that Terry McNabb was talking about at the BC. Did you see Terry's talk? Terry McNabb's talk, the fellow from Washington, and he's the pesticide applicator out of Washington, and he's got a parrot feather solution and he's got a milfoil solution, 100% effective on the milfoil.
I've been using biochar.
Sorry,
I've been using biochar.
biochar. Okay.
Charcoal in sacks,
Yeah.
and it's completely knocked down my milfoil, and it ate my algae one
Wow.
in 15 days. It was pretty impressive. And that's just charcoal that I made in
Yeah.
my wood stove.
Wow. That's dynamite.
I know.
Huh. Interesting. We have to do monitoring, obviously, to make sure that we're having an effect. So obviously, public health issues, drinking water supplies, water quality, ecosystem stability, maybe wildlife or livestock health. So those tests are always being done. There's one of my staff just happy as a clam. We got lots of watershed controls you might need to undertake to manage your nutrient input. You want to manage your point source controls. Obviously, that's the province's job and the Fed's job. They're the ones that control whatever comes out of any pipe anywhere, right? That's the federales, and there's a map online, a GIS map. Anything that's got an end of pipe, it needs to have a permit, and there are controls around how much and when and all that kind of stuff that can come out of that pipe. The tough one is the middle one. That's the non-point source control. So those are the non-regulated stuff that comes running off the streets, stuff that comes running off agricultural fields, stuff that runs whenever it rains. That's the non-point source. And 20 years of water council, that was the biggest problem that we found everywhere. And that's worldwide, is managing non-point source. So that's everybody is in the same boat dealing with that. And then of course, methods to do non-point source pollutant trapping. So constructed wetlands, constructive riparian areas, or other methods of containing that runoff water and somehow treating it effectively. Point source controls, obviously single point source location. So there are regulations, rules, laws in place to deal with that pollution. And of course, as a basin society, you can deal with the companies that are putting those in and lobby the government to have them lower their approved discharge limits and when they discharge and all that good stuff.
Actual enforcement.
Yeah, there is none.
Nothing better than having the best laws in the world if there's no enforcement.
Yeah.
No, absolutely, absolutely. I'm a bit of an environmental terrorist, so there are other ways. Embarrassing a company. I'm the guy that came up with using caffeine to find out where sewage is being released, because cows don't drink lattes.
Yeah, they don't.
So if I find caffeine in the water, I know it's from a human source. Then we can use, lipid tests and cholesterols and things like that. So I started off with caffeine. We went into some fats. We went into agricultural pharmaceuticals, looking for those signatures. And now it's all the way down into eDNA. And literally, I can tell you if it's cow, rat, pig, muskrat, who pooped in your water. I can tell you who.
So
yeah.
You have access to that technology?
Yep. Oh yeah.
Okay, good.
Mm-hmm. I've done microbial source tracking for 10 years, and it's so refined now. It's so powerful and it's so cheap now.
Yeah.
We can do it everywhere.
So we did the monitoring of the Oakside watershed, the lower watershed, tributaries empty to Cow Bay directly and Cow Bay Marine.
Yeah.
And the three of us in the Basin Society, Dave, myself, and then wrote up the results. And so everywhere we look, we have E. coli and fecal polyp.
Yeah.
But we would really like to know the source.
Yeah.
Is that bovine? Is it elk? Is that...
It's critical from a health perspective too, because Canada goose poop won't kill me.
Yeah.
Cow poop will. So I'm very concerned. That's why I'm fecal coliforms. It's stupid. It's pointless data. It's pointless to know because I need to know whose poop it is.
So if we ever get to the point where we have funding for that,
Yeah.
come to you.
Oh yeah, for sure. And then, then there's, cryptosporidium and other intestinal parasites like that we could and should be looking for as well, because they're particularly nasty too.
What's the analytical cost of caffeine? Is it a relative?
I'd have to look now. When I first started, it was about $1,200 a sample.
Yeah.
And when I stopped being asked to do that test, it was probably 200.
Still fairly.
Yeah, it was, but I have to look now. It was a GCMS test.
Yeah.
So they ran it through the gas caloric radiograph twice. But now there's a whole host of pharmaceuticals they'll give you. So it's not just caffeine. And every year the resolution gets better and better and better. So I was in the nanograms. I got out of that. I probably haven't done that in 10 years now, but it was in the nanogram range that I could find.
Not every lab would do that.
Oh God, no. And nor would they. The technicians, they had to run my samples first thing in the morning, and they couldn't have had coffee. It can't be on their breath. It would detect it if they drank coffee. They can't have it in the lab. Like, it was ultra clean, and their staff had to have not had coffee for 24 hours when they worked on our they hated us. And of course, my staff couldn't have coffee or anything either, right? So that
Point of caffeine or just right
Yeah.
kitchen.
so
Can't we find another indicator?
well, you just got to find a good Mormon lab to work with,
Yeah.
right?
Yeah, there you go. Absolutely.
We'll be all set. Non-point source, again, we could talk all night long about how do we deal with non-point source control. There's all sorts of education that needs to be done. There's working with agricultural groups. We beat zero till into every producer, 20 years ago, 25 years ago, doing no till. We've got them down to using, slow release phosphate fertilizers, but it's eliminating those land use practices that release nutrients. It's the construction practices. It's good housekeeping. It's good. It's just good construction practices. It's a whole host of things, and it involves every level of government. It involves everybody in the watershed. So literally, it's all of us together, right? As your group knows.
Yeah, you should see some of we had drone footage of the South Shining Creek, which is the input to the main input.
Yep.
After a rain event, it was just
Brown
mud.
chocolate milk. Yep.
Yeah.
Yeah, and that's the kind of stuff. Get that out, get the public seeing it, cause a ruckus. That's why I love doing, the farmers would hire me to do caffeine testing to show that cottages were dumping their poop into the lake. The cottagers would hire me to do pharmaceuticals on, veterinary pharmaceuticals to show that it was cows pooping in the lake. So it was really fun work that I got to do.
Well, when the pit breached on their Friday the 13th.
Yeah.
The VHA issued a do not touch the water.
Oh my God.
Do not touch.
Oh,
But they
God.
didn't put any notices up anywhere. They just put it on Facebook.
Put on Facebook, sure.
Yeah, so I ran
'Cause-
around and made signs and put them at the end of the lake. But that day, the next day, when I got up and the flume had made it down to where I live on the water, my dogs went running down to the lake to go have a drink as usual, and they wouldn't drink the water. They put their head down, and stopped, and they sat there and they stared at the lake for like a half an hour. I bawled my eyes out because my dogs licked their asses and drank the bottles, but they wouldn't drink my lake anymore. And you know what VHA said? Oops, we may have overreacted. And then Mary Pollack, our environment minister, said, it looks bad, smells bad, tastes bad, it's gonna stain your laundry, but you can drink it. I have a bottle that says that. I should have brought it. It's brownie. And that's what VHA said. Yeah. People were bathing their babies in this, people were making their coffee, stuff in the lake. I know people with dogs and the stuff that they have cancer. Yeah, okay, fine.
Wow.
Yeah.
Wow. So it sounds like you might have more serious problems than non-point source pollution. Obviously, lots of ink has been spilled on all of the things that we can all do. So, pick a path. Each one of these you could do a fact sheet on, put it on your Facebook page, put it on, put it out in your educational materials. Doing public education obviously is a big part of what I do, what I get involved with, putting materials like this together. So the Summerside Lake folks, I've probably produced a dozen different fact sheets on different things that their media people can go, oh, we got Swimmer's Itch this week. Okay, Swimmer's Itch. They can write an article on Swimmer's Itch, just from what I've prepared for them. Same thing with this kind of work as well. So lots of things that we can all do in the watershed, as long as we're all on the same page and everybody wants to, in the end of the day, everybody wants to have better water quality, which we all do, I think. What are some things that we can do as average citizens, cottage owners, folks that live around the lake? There's all sorts of things as a homeowner, what we can do for non-point source pollution management. That pet waste one, I never realized how much, fecal coliforms come off of a dog park. It's huge. There's been studies, lots of studies in the States and in the UK that they've looked at pet wastes and the amount of phosphorus comes off just pet waste. But obviously having healthy functional riparian areas, having the proper vegetation, don't mow all the vegetation all the way to the water's edge because you want a nice view. We need to have the proper vegetation that's there. Talk people out of hard armoring, riprap, rock riprap, retaining walls, all that kind of stuff, and try to go with, natural solutions that hold the bind and keep that soil held together.
What we build water walls on the shoreline.
Water walls, perfect.
Yeah.
Yep.
So we've got
Wonderful.
several of them on the lake that are greatly established now, with
Nice.
all the natural plants that are already growing.
Very happy to hear that. We've got, in Alberta, there's lots of lakes with hard armored solutions, and of course you get giant ice scour, and you've never seen ice scour until you've seen it in Alberta. You will get literally a glacier that will blow up and come up on shore for 40 or 50 yards. And I've seen sheds just leveled and just comes right up and knocks over houses and stuff, but it'll tear the hell out of the shoreline. It'll rip it right out when it comes up on shore. Septic systems, dumping dye down the toilet and flushing it and see if it ends up in the lake. There's all sorts of little fun things that we can do. Rhodamine dye. Yeah. Oh yeah. Planting veg. Anyways, I don't need to go through all these. These are all tips and tricks and things that you would look at. So in conclusion, what is blue-green algae? It is not an algae, it is a bacteria. And it's a naturally occurring bacteria. It does grow in the presence of nutrients. It does not like oxygen. It likes lots of phosphorus. It likes still conditions, and there's lots of sunshine, and it will bloom. It can't form in running water, so you won't find it in river systems. But it is nasty. What are the risks of algal blooms? Human illnesses, irritation, and other health issues, animal illnesses and death, and contaminations of vegetables and fruits and those sorts of things.
The reason that it doesn't form in running water. What is it? Is it just a physical aspect?
It's a physical thing, yeah.
It's probably the oxygenation of it.
It might be the oxygenation of it too, but yeah, it wants still and glom together. Yep.
Okay.
Yeah, that's a good question. In conclusion, like I said, there was at the end of the year, there was 39 lakes that Alberta Environment monitors, and there were 44 advisories. So there were more advisories than lakes that they monitor. And of course, beach and lake closures, we could click on that right now. And that'll probably take us to an ArcGIS map, but I won't do that. What contributes to blue-green algae? Calm, undisturbed waters, high nutrient sediment, high levels of phosphorus. How to control that algal growth? Limit fertilizers, use low phosphorus detergents and cleaning products, and of course, limiting that agricultural runoff. In Alberta, it's incredibly predictable. If I know the manure loads in a basin, I can tell you the water quality, and I don't even need to put a bottle in the water. It's on a regression line, it's like a 0.96 relationship. Like I can tell you very closely how bad your water quality is going to be just from the manure loadings in an area.
One thing we're finding in the lake, with the milfoil, in conjunction with the milfoil, you have perimeter vegetation that's it's all being enhanced by the quiescent, like the milfoil stops the water. Sediment forms inside the milfoil.
And then you get your algal blooms.
And it just keeps building.
Boom.
It's beauty.
Yep.
So is that I'm just wondering what the nutrients then, the nutrients are obviously would be released from that sediment accumulation then.
Yeah, as soon as you get the right conditions, the phosphorus is going to dissociate from that particle, and typically when the water goes anoxic. So that's usually what, and I haven't told you that story, shoot. I'll do it real quick. Phosphorus binds to clay particles, so it's negative, they're positively charged, and the complex stays fairly stays stuck together until you get anoxic conditions. Changes the redox potential, changes the way the iron complexes with the clay, and then it lets that phosphorus go. So you get, you could have a situation where you got a stratified lake, you've got all your oxygens up top from the wind mixing your surface layers, you've got a stratified lake, and then you've got this anoxic bottom. And as soon as you get that anoxic bottom, phosphorus is going to be released from your bottom sediments, and it's going to continue to cycle down there. La 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 la. You know, it might be happening all summer long. No big deal, right? And then the water temperatures cool off in the fall. The water temperatures now can mix,
You get turnover.
and you get the turnover, and now all that phosphorus barfs up into the surface, and then it stimulates all that growth.
That would occur in this lake in November, though.
Yep,
Would
yep.
that blue-green still be able to grow and?
Yes. Yes.
Okay.
Blue greens can form under ice. So if you've got lots of times, I've seen you've got an ice covered lake and not a lot of snow cover, but sun shining through that ice, and you get the ice comes off and there's an algal bloom. Or sometimes guys will be punching ice fishing, they'll punch a hole and they'll bring up this giant like screaming pink colored algae. It's called plankthrix, and they'll stain the snow all this crazy pink color, and that's a blooming algae under the ice.
Wow.
Yeah, so they're
We've done profiles in the lake, and it's clearly anoxic.
Yeah.
The bottom 10 to 15 feet.
Yeah,
Totally
yeah.
anoxic.
okay.
Yeah.
So you'll probably see that that turnover phenomenon bringing up all that released phosphorus. Now, what's good about that is if you're going to put a phosphorus binding product in, that would be the time to add it, is in the summer when it's all trapped down here, right? We can target it.
Like you could introduce it by a pipe or something.
Yeah, inject it, deep injection.
Below the thermocline.
Yeah, pump it in below the thermocline. Absolutely. I would put in alum below the thermocline. That would be a real innovative way of dealing with it. Another option would be to bring it up and treat it and return it. So that's something else I've been working on sort of in the back of my brain. So here's what we don't want to have. Oh, here's what we do want to have. Oh, so this is right after an alum treatment. It looked that nice. I was really lucky. This is Lake Summerside in Edmonton, and I've been managing it for the last 3 years. So yeah, it's a beauty. And then I'm managing mahogany in Calgary right now as well, and it's the biggest one in Alberta. It's a huge man-made complex, and they've got other physical issues beyond the water quality. They got very, very fine particles that won't settle, and so the whole lake is this kind of chocolate milk color.
There's some comments or press questions in the chat.
Yeah, you bet. So there we go. So that's the end of, that's me. All these links are hot, so you can click on any of those and see any of our good stuff. But I will pop over to the chat now. And is it all right if I just answer these?
Yeah.
Okay, so Joanne asked, all good, sound is great. Do we have a provincial water council?
BC, it would be MOE.
So your lands and forest, your forest department manages your water here.
No, there's another water resource stewardship ministry just recently established.
Was it?
Yeah.
Okay.
But
Because all the work that we've done on water quality is all done through the MOE.
yeah,
I don't know what that's the acronym for Ministry of
This environment, yeah.
But I'm not sure they're called that. They changed their name.
No, and now the land and forest, I believe.
Yeah, it's lands and forest.
It's just the regulatory side
Okay.
of the government, but MOE
it's
was always.
climate change strategy.
Oh, it's.
Oh, there you go, we're talking climate change.
But I
So
think the acronym is still MOE.
So I think, Joanne, the answer to your question is no. Our Alberta's Provincial Water Council did want to reach out to BC and Saskatchewan, and they did not have. Now there is a federal water group that's being formed. It was set up in 2018, and they are just reaching out to the Alberta Water Council recently to start having conversations. And I'll know more about it at the end of the month. They're making a presentation to our water council at our October meeting next week. So I'll know more about that federal group
Is that
soon.
under Environment and Climate Change Canada?
Yes, yeah, it's under ECC. Yeah, you bet.
So the new ministry in BC is the Ministry of Water, Land and Resource Stewardship, and this Nathan Fowler is the minister.
Joanne Gregory says septic system is a concern question mark, but I guess the contaminated soil is the biggest concern. Yes. I'll just say yes.
Just so you know, Jay, what's happened is the lake level is coming up, like they have a weir.
Yep.
And they're regulating it to contain, like, at full pool, at high water.
Yep.
To be higher than it would have traditionally.
Right.
That's occurring during the winter.
Yep.
The problem with that is some of the septic fields will.
Right, you put them underwater.
Not working.
So my father-in-law told me about the houses that he built down here not that long ago, and some of the septic fields that he built and how they were running straight into the lake.
Yeah.
So that's
Yeah,
obviously
we're
that's
pretty sure there's a huge, that's why.
Yeah.
When you're talking about identifying the source of the.
Sure.
The fecal coliform.
Yep.
That's important.
So in 1998, they raised the level of the lake by 2 feet.
Whew.
And drowned our shoreline in the bushes, and of course put septic fields that much closer. That caused a huge, like the water quality just started going straight down, like years after that. We had Dr. Neonage from the University of Victoria testing the water, so that made a huge concern because they drowned our riparian area.
Yeah, that's awful.
Yes.
Oh my
And
goodness.
they didn't tell them yet.
Oh.
And flooded our houses.
Is anyone familiar with what is called a California septic field? When I was living on Cobble Hill Road near George Bonner Middle School, I believe someone was trying to get a permit. Opie.
Is that using plants?
I don't know. California septic field, Pops? Know anything about that? Okay, sorry, don't know. Where can you buy peroxide? Peroxide? You can buy that darn near anywhere, any chemical, you want to buy big bags of it. You want big bags of the sodium. I can buy any chemistry, basically any chemical company in Edmonton. I was buying it from out of Leduc, so it was very local, and they trucked it to us for free, which was great because I don't like storing it. I need just as much as what I need for an application that day, and that's it. I don't want any being stored. It's a powerful oxidizer.
Yeah.
So you don't want it sitting around in case there's a fire or something. So I just want to use what I use. So the peroxide you should be able to get from any local chemistry place. If you look up Air Liquide or companies like that, they carry it. And then the Flock and Lock I got out of a trout supply company, like the fisheries folks. The fish and they supply all the people that have all their own private trout farms and the public trout farms. So I got to know them because I was sitting on the whirling disease task force with them. So I get the Flock and Lock from Rocky Mountain Trout, and again they also delivered it sort of the day of, and it came in a liquid jug, and we just mixed it with lake water and then we applied it.
Okay.
Yeah, and that's it for the questions.
Is there anyone in the Zoom audience that have additional questions?
Any other questions? Zoom audience folks, and I'll try and get
stop sharing the screen to
Here we
back
go.
to the video.
There we go.
I can see some, but not all.
Yeah, if you stop.
Okay, I'll
Just
just
say stop share.
Just stop.
And then we'll get the full screen.
Stop share with the red button.
Thank you. The bright red button, Jay. There we go.
And then you can enlarge that too.
And then go, boom, let's get rid of.
So in the meantime, Jay,
Yep.
for your information, I looked up if cyanobacter have Rubisco as the carbon dioxide fixing enzyme,
Yes,
and it does.
Rubisco, okay.
But the catalytic site also binds oxygen. So if you oxygen is high enough, the cells can't fix carbon dioxide.
They can't.
Yeah.
So it's
So it's the enzyme that fixes carbon dioxide. And it can also bind oxide. And that's was the principle of trying to get rid of duration. Milfoil is the oxygen.
Yeah.
I don't know because duration milfoil also is a resistant enzyme.
Interesting.
Early in your talk, Jay, you talked about, you mentioned red tide, that it wasn't just fresh water, that it would, you will get cyanobacteria in salt water.
Yes.
Forestern water.
Yep.
So is red tide then, is that the result of the cyanobacteria?
It's
Because it's shellfish, isn't it?
yeah, it affects shellfish. Yeah, but it's
So
the same mechanism.
They're filtering it out of
They're
the
filtering
water,
it out of the water. That's right.
accumulating toxins, but it's cyanobacteria that they're.
Yep.
Okay.
Yep. It's and it could be might not be cyanobacteria, might be cyanoplankton
Yeah,
or some other host,
yeah,
but it's another toxin producing vector.
yeah. Okay.
Yeah, because I got that question at the circuit and I couldn't answer it, and that's why I specifically looked that up.
Yeah.
Yeah.
Okay.
So wetlands are still one of the best things out there.
Absolutely.
I build floating wetlands.
Yeah. Okay.
Because they drown my shoreline, I don't have any soil there anymore. So I've just taken docks and planted went shopping along my shoreline and put them on my docks, and now I have these huge wetlands with cattails and reeds and hardtack and etc. And I've got
Oh, wow.
fish living under it. I've got log boom wetlands that I
Yeah.
planted all the same plants and log booms off my shoreline to stop the wave erosion of my shoreline.
Yeah.
And create these wetlands, and the fish habitat underneath there is insane. I have a blue heron that hunts twice a day now. And I mean, it's just the most beautiful thing, and it was fairly easy to do, but I know my water is clean because I can see it.
Yeah, sure.
It's amazing, yeah, so, and I use biochar bags, hanging off the wetlands to absorb the nutrients that are in the water.
Wow. That's
So,
awesome.
I've been playing with biochar for a few years now, it's been
Okay.
working really well.
Wow. Wow.
Well, when you stand there and see what they're dumping into your lake, you kind of find solutions, but yeah. Problems is the solution, so. Wetlands, but yeah, thank you for this, this was awesome, very.
pleasure.
educating.
My pleasure.
Yeah,
I definitely enjoy it, and I'm still learning more. Like I'm on this EPA. There's a 4-day course I'm in the middle of right now. This 4-day cyanobacteria
That's
course. US EPA, yeah, not Alberta EPA. Why they change an acronym to that? But anyway, and it's tomorrow. It's next Monday and next Wednesday, and it's free. So if anybody's interested in that, so I've been getting a ton out of that course.
Is that online?
Yeah, it's online. It's from 10 to 2 those days.
Yeah.
Yeah, and solid presenters, like all those lipid slides and all that off the top of my, I stole all them. I stole all those from Barry Warner.
We should get the website from you or whatever.
Yep.
So that we could,
Yep.
let people know.
yeah,
Yeah, it's I think it's just called Cyano Symposium. Can I use the Google here?
Yeah.
I will. What's your browser? Is that no?
No, it should be Edge, but I don't know. It's the problem with that taskbar is there's none of the apps are in the. You have to go to the little thing on the corner there to get the app.
We'll figure it out. So it's called EPA Cyano Symposium. Boom. Should be the first thing that comes up. Yeah, there it is. This guy. Yeah, so you might want to send that. Put that up on your Facebook page.
Yeah. USDP Symposium. Okay, we'll get that on the Facebook.
Yeah.
Or on the.
I've got it here, it's October 16th, 18th, 23rd.
Yeah, that's us.
Okay.
No, I'm not seeing it come up here, and I don't know why. That's this is the bulletins that's coming up. It's good. Yeah, here we go.
Yeah.
So we had Barry Rosen, that's the guy that spoke yesterday, and Jennifer Graham. So there we go. Yeah, day 1 was biology, ecology, and taxonomy, Barry Rosen. So that's the guy I stole his slides. And then sampling bacteria was really good too, Jennifer Graham, and she's more on the drinking water side. And then we've got toxin deep dive tomorrow methods, monitoring from space, because there's a whole ton of satellite work that's being done. We're even doing that work with Alberta Lake Management Society with researchers from U of A, because we go out and grab water samples at the same time the satellite's overhead, and so we can verify all our data and compare it against the model. So that's pretty fun work. And then the last day is duels and federal funding, and yeah, so that'll be really fun.
So you just register, it's free.
Yep, it's free.
Yeah.
Okay.
Price is right. Free education. I'm all over it.
Absolutely.
You have to register for each day separately, so you can register for day 2.
Yeah. Sounds good.
So
Okay.
just click on that and away you go.
Mhm.
It's awesome.
And it's from what, 2 to 4? No.
It's Eastern time.
Okay.
So yeah, it's 10 to 2 our time.
It's 10.
Yeah, 10 to 2.
Yeah, 10 to 2.
10 to 2 our time. So it's 4 hours. It's a lot. They take regular breaks and stuff, so I'm able to.
Are they recording them too?
Yes, it's all recorded. It's all going to be on the website when it's all done. So you can do it live, or you don't even have to. Yeah, you can
Okay.
just go to their website, and the presentations from yesterday are already up.
Awesome.
Yep. So that's solid. Yeah. And I hope folks on the call can see this. I'm not sharing this page, am I? Why don't I, can I share this page in Zoom?
Good question.
Maybe I will try and do that. Mr. Mouse. Oh, it's one of those mice. I will.
Yeah, you could go back to the Zoom meeting and then share the screen.
Okay. This page
You
right
can
here.
always pop the link in the chat too. That helps.
Oh, there we go. Why don't I do that? Thank you for the tip. Yes, that's easy. Boom. I will pop the link in the chat. I just got to figure out where my chat is. So we're done with that. Treating killer algae. We're done with that.
Gotta get
There, here we go, right here. So I'll just pop that there. Did I type that fast enough for everybody? There we go. There's the link is in the chat now. All right.
Well, thank you very much.